And what are you going to be talking about today then? It looks like best practices in implementing container image promotion pipeline. Sounds interesting.
That's a mouthful, but it's basically how we deal better with Docker images and where it usually bites us in the arse, and how can we avoid it for the future.
Cool. And your role, you're at JFrog, you're a developer advocate at JFrog?
Yeah, I'm head of DevOps Advocacy in JFrog, and also Chief Sticker Officer, which is a very, very important role, as we know.
Yeah.
So it's basically speaking and stickers, the important parts of DevRel. Yeah.
And how has the role of a chief sticker officer been affected by obviously this working from home?
No, I cannot ship stickers anymore.
It must be tough.
Yeah, absolutely.
So Baruch, we're against the clock. I don't want to take any much more of your time, so I'll bring your presentation and I'll pass it straight over to you.
Perfect. All right. Okay, so let's see how this thing works. If I do that, you should see the next slide. If I do that, you should see the next slide. Perfect. Yes, it works. Now, yeah, that's one of the disclaimers that I wanted to make, and that's although we have containers in the title, we're going to talk about Docker because everybody say containers, but mostly mean Docker. And with Docker, we have, and we as an industry have a very interesting relationship. I would say it's love and hate relationship, because it is amazing. It is an amazing tool. It definitely revolutionized everything we know about software delivery, no doubt about it. But the more we learn it, the more we discover stuff that we don't really like. And this is a Venn diagram, and you can kind of try it for yourself in mind and think about software that you like and software that you know really well, and you will see that there are really not a lot of interchange there. And Docker is not an exception. And I think most of the problems that we see when we speak to our users and customers and friends in the industry and the community is that a lot of people find it hard to completely trust what Docker is doing for them. In the end of the day, they have some software in production that they should have confidence that it's a good software, and it's not always the case. Well, sometimes it's fine, sometimes not so much. So this is what we're going to talk about, how we're going to fix it. As Simon already mentioned, my name is Baruch Sadogursky. I'm the Chief Sticker Officer and Head of DevOps Advocacy in JFrog. On this slide, the most important part is my Twitter handle at JBaruch. I hope you'll find me useful and entertaining and follow me on Twitter. Don't worry, my Twitter handle is comfortably on every slide. This is a disclaimer. It's more like a California thing, and it's late in California, so I don't know if anyone from there listening, but I'll make it anyway. This is an amazing chart from an amazing book called The Culture Map by Erin Meyer. If you work in multicultural environment organization, and you definitely should read this book. And that's a chart that plotting cultures of emotional expressiveness axis and confrontational axis. And you can see that the most emotionally expressive and confrontational people are from Israel and Russia, and I happen to be from both. So I might say some controversial and offensive things during today's talks. Please don't be offended, or do be offended, but at least know where it comes from. The most important slide of this presentation is this. I prepared a special page for you, jfrog.com/show notes. You go there after the talk and you will find the slides already there, the video that will upload shortly, all the links that I mentioned, including the culture map, by the way, a place to comment, to rate this talk, and a very nice raffle with a very nice prize. It's a Nintendo Switch, definitely worth participating. So, if you don't remember the URL of the jfrog.com/show notes, it is also in the bottom of every page. Very, very simple to remember. Okay, now let's talk about patterns. We're here to talk about patterns, and when we encounter something new, for example, promotion of images, we usually ask if we already have an existing pattern. And should we adapt it? Should we change it? How should we change it? Now, with promotion of artifacts, we're doing them forever, because that's actually continuous integration pipelines. And of course, we know how to do it. Basically, what we do is we implement a promotion pyramid when we have two accesses, the deploy time, and this is how long the build takes, and the amount of binaries, and that's how many binaries we have. In the beginning, the tests are very, very fast, but we have tons of binaries that will be your unit tests. As this pyramid progresses, less and less binaries survive those tests, and the tests take more and more time. In the end of the day, we have the chosen ones which are of good quality and also deserve to be promoted to production. So this is not new. I really hope you all know and use it. Now, what is pipeline? Pipeline is, and that's the view of kind of the same pipeline but laid on the side. The pipeline is once you build your artifacts, once you finished your CI, your build, this is where the pipeline actually begins. We have those artifacts that we promote if quality requirements are hit between quality gates. So those locks are the quality gates. And then in each and every environment, we deploy, this set of artifacts that are ready for this environment because they pass the quality gates. And then this is how the artifacts are promoted from one environment to another until they get all the way to production. Now, again, this is not new. I really expect you all to actually know that. And in the end of the day, what's different in Docker? One of the things which are different is that Docker have a very, very powerful build system built inside Docker, and that's the Docker build command. Right? You just write a relatively simple Docker file, you build it, it creates a Docker image very, very fast, and instead of starting dragging those large images around from one place to another in your pipeline, it's very tempting to actually Docker build all the things, and instead of promoting the images, promote the Docker file itself. And promoting of a text file is really something really simple to achieve. All you need to do for that is, just tag it in Git and saying, now this Docker file is development, now this Docker file is staging, and now this Docker file in production. So instead, in our diagram here, instead of promoting build the artifacts and promote it, we promote the Docker build file and build it in each and every environment. This is easy and very tempting. Now, the problem with that fast and easy and cheap builds are not always the way to go. Running build in every environment is not a really good idea. And it's not a really good idea. I'll explain you why. Now, for this slide, when I prepared it, I wanted to create the most hideous, the most unstable, the most horrifying Docker build file ever. And it was supposed to be completely fake. But then I just went to the internet and I discovered that I don't need to fake anything. The reality is above my wildest imagination. Let's look at this file that I actually found used in production by a lot of folks. And obviously the link to the proof that that's a real file is in JFrog.com/show notes. You can go there and find a link to a Git repo where this file actually exists. So what's the problem with this file? Everything. Every line in this Docker file retrieves a latest version of the dependency each time it is built. This is a latest version. This is a latest version. This is a latest version. And this is latest version. Everything is relying on latest. Now, you can see the problem. Obviously, when I'm going to build this file multiple times during my pipeline, I have a very high risk of actually getting different Docker image every time. And this is where our insecurity about Docker actually proves to be right. If I wrote this file in development and created a container that I'm happy with, but during my pipeline, each time I build, I get a different container, what I will end up in production is not what I assumed I have in production. And that's exactly where the problem is. So let's see if we can fix it. If we can fix it. Obviously, there are some fixes. So here is an example. I can actually nail the version of dependency of my base version. Will it fix it? To an extent. Obviously, it's better, but it is allowed for images to actually override the versioned image, because tag is not immutable in Docker. I can push new Ubuntu 19.04 every time and still call it Ubuntu 19.04. Will I do it? Probably not, but sometimes also yes. For example, if I want to push a security update, it doesn't mean that I don't need to push a security update into the same version, but it definitely means that this declaration is not stable. What is stable is checksum, because checksum always relate to a defined set of bytes. So this never changed. The problem is this is completely not useful, because if I will ask you what version of Ubuntu I refer to, you will never know. More so, you won't even know if that's a valid checksum, or is it just me fall asleep at the keyboard while waiting for my session, like Simon did. Maybe it's not valid at all. Now, can we fix those? Probably we can. If you know Python and if you know Node.js, you know how to log the versions of those. But let's say, how about this? How many of you know how to nail all the versions inside Maven? I mean, Andres knows. How many people know except of Andres? That's a good question. And how about that? I might have a script that just goes to the internet and download random stuff. How can I log the version and make this immutable? Well, I probably can't. So basically, my point is, this is where the problem is. I have Docker build that I run every time, and I'm in danger of having a different image built on every stage. So this is a no-no. When we want to build a promotion pipeline, we have to do it with immutable and stable binaries. What we want to get is this. We build it only once, and then we promote it through those quality gates, the same artifact that we created, promote through the pipeline, through the quality gates to production. And I mentioned gates a lot. What's the story with gates? Why I'm so obsessed with gates? The thing is, it's very important to have those gates. So QA won't test images which are not ready to QA. We won't stage images which are not ready to stage. And definitely, we won't get anything that is not ready in production to production. It sounds obvious, but the question is how easy it is to create those rigid quality gates. And let's see what our options are. How do we separate dev from prod? That's the question that we need to answer. So first option is using Docker labels. I can label an image and say, well, this image now is stage dev, stage QA, stage prod. This is nice, but I cannot attach any kind of role-based authentication to the labels. It means that if I have a production cluster of Kubernetes, it can access the images which are labeled to development with the same ease as they can access the images which are labeled to prod. And that's obviously a problem. We want to prevent that. Let's see what other options we have. This is not so good. The second one, using Docker repositories. We're going to talk a little bit about the confusion in the name repositories, but in Docker, repositories are directories in your registry. This is nice. I can have directory for dev, for staging, and for prod, let's say, in each and every image that I have. But and there is a role-based authentication, so I can do it. But for each image I need to create new set of those directories. So this is better, still not very useful. What I actually want is separate registry per environment. I want this to be a registry that only the integration cluster can reach, this to be a registry that only a system testing cluster can reach, and this to be a registry that only the production cluster of Kubernetes can reach. So this is what I want to do. How hard can it be? Well, not so easy. Sometimes we have very strange limitations on our systems, and you may be old enough to remember the limitation of 640 kilobytes of RAM. That should be enough for everybody, according to Bill Gates. Docker has a little bit the same. This is how Docker tag works. When you push something or tag something or pull something, you mention the host, and then the port, and then the user, and then the name of the image, and then the version. This prevents us to actually mention which registry do we want to address inside a single host. So how can we have more than one registry per host now if there is no way to specify it? Now, how can we support this? How can we say host and then Docker dev for development registry and Docker prod for production registry? How can we support that? The problem is no one thought about this scenario. And now, obviously, everybody use the Docker tag specification, and it's very, very hard to use. So first, we can panic, but also we can actually use, for example, virtual hosts or virtual posts. We can come with, so this is how it works. When you run Docker tag, it actually translates to host and port and then the name. What we can do is, so we have, we can rewrite this URL to actually be this URL. And we can rewrite it by saying, okay, I create a fake port, 5001. All the requests to this port won't be routed to a real port, but it instead will be routed to some URL, which actually be a registry, a separate registry under my host. That's one option. The other option is abuse. We can actually use the username here to express a registry name. If we don't separate our images to include a username, and most of the people don't, this token is actually available for us to use it as a Docker registry, and then we don't need the URL rewrite, and we don't need the reverse proxy to do the rewrite for us, which is cool. So, okay, so now we have different registries per host, and the next question will be, how do I promote? How do I move the image from dev to staging to prod? Should I pull, retag, and push? With large Docker images, that would be obviously a disaster. So instead, here is a solution that might work. This is an example of such a tool, and this is a free JFrog container registry that you can download to the on-prem or get a free in the cloud. And you can see here how we in JFrog tried to fix that. That's not the only tool that uses it. So look for the right tool for you. This is just an example. So what we have are three different types of repositories. The local, and those are the registries. You can have them as much as you want. The remote, which is a proxying registry for your dependencies that come from outside registries. And virtual, that kind of exposes any set of repositories that you want from from the other repositories, from the other registry that you have. And then you have your developer that only interacts with this virtual registry, and they have everything for their disposal. They can do whatever they like. They can push, they can pull, etc. We have our CI server, be it that's Tecton, but it can be Jenkins, it can be JFrog pipelines, it can be whatever it like. It builds those Docker images and then pushes them to the right registry, and that will be the dev local, but then using a simple API call, or in our example also JFrog CLI, can promote those images from one registry to another without actually changing anything, because the underlying file system remains the same. It's just the visibility of the image that changes, and it appears in different registries. And that's exactly what we need, because then all our clusters actually can only see one registry at a time and can only see the correct registry that they need, but we also get the promotion, which is absolutely free. Now, as I mentioned, there is a little bit of confusion between registries and repositories. Just to clarify, a repository in Docker is a top-level directory in a registry. Repository in the rest of the terminology is the registry. So when I talk about repositories in Artifactory, I actually mean different registries. And this way of going about it provides us a three-way win. So we have single point of access to multiple registries when needed. For the developer, uses the virtual registry. Completely isolated environments. Our clusters can only see one registry at a time, and immediate and free promotions because when we move images between the registries, we actually don't move anything. So that's a win-win-win. Another issue that we encounter a lot is obviously latest. Should we use it? Should we not use it? It's very comfortable, but it also very dangerous, because when you use latest, you don't really know what version of the Docker image you use. Inside JFrog Container Registry, there is a solution for that as well. So you can see here how in the latest, we actually can attach any metadata, obviously, on any artifact. But here, it's an example of how we use these properties to say to which version this latest actually refers to. We say this latest is actually the same as version 26. And this is how we have simplicity of the latest, but also always knows what version it really means, as long as we promoted the immutable artifact and did the right thing. Now, obviously, we need to take care of other dependencies as well. That's for security and for immutability. And this is something that you can do as well. With the proxying registry that proxies others, you can cache your from images and make sure that they don't change in your environment, in your build, even if they changed in Docker Hub, because you cached the version that you actually use. And then what you put inside your image is also immutable, because it also comes from the JFrog Container Registry. The generic repository allows you to have any file, for example, your infrastructure dependencies and your application itself. So when everything comes from your local artifact repository manager, you are actually guaranteed to have a repeatable build. So on your dependencies, your base image cached from Docker Hub, your infrastructure saved for whatever you use, and your application files as well. So with that, conclusions: you build only once, and then you separate environments, and you promote what you have built through those environments. You own your dependencies, and this is the basics. So with that, thank you very much. I'm JBaruch on Twitter. Now, for sure, you want to follow me. When you praise this talk on Twitter, don't forget to mention all the TalksConf, because they will retweet, and we both will get some promotion out of it. And as I mentioned, jfrog.com/show notes, the slides, the video, all the links are there. And obviously the amazing raffle. If you want to scan a QR code, you can do that as well. With that, back to Simon. Thank you very much.
Awesome. Thank you very much, Baruch. And for everyone who has questions, you can add them in the Cloud Native Slido, and there's also the Cloud Native Slack that you're welcome to ask questions in. So Brendan says, "Very well done. Thank you very much."
Thank you very much, Brandon.
So Baruch, what's I think when building regularly is one of the kind of things that very often eliminates vulnerabilities. Building too regularly and the build, as you rightly say, kind of gets unstable because you don't know what you're getting. So where's the balance in terms of how often you think people should rebuild? Should they rebuild periodically? Should they rebuild based on security vulnerabilities, or should they be, should it be something else?
Simon, I expected this question from someone who works for a security company that deals with vulnerabilities. Thank you. And that's a great question, because I left a bomb over there when I said, oh, no, don't take the latest Ubuntu because they will push security vulnerabilities and it will break your build. And I could imagine Simon's head goes like, what? Shut up. Well, it is an interesting dilemma, right? Because you do want sometimes to get the latest Ubuntu 14.04 because there are security vulnerabilities there. And this is fine. You should get the latest, but it shouldn't be the one which is automatically used as the base image for your production environment. So what you do, you have your experimentation environment in which you can even be on the latest. You know what? Run the latest from Docker Hub and use the latest Ubuntu and see if the build breaks. If the build doesn't break, then you embrace this version and you say, oh, you know what? This is still good. Now I take it, I own it, I cache it in my registry, and this will be my new base. What we don't want is every time we build something, especially when it automatically goes to production, is just download random files from internet. This is a no-no. Checking periodically for new versions that include important patches as security vulnerabilities is absolutely a best practice.
And who do you feel should own that decision in terms of when something gets promoted into the registry?
So this we have now. It's not about who, right? We don't want people in process at all. What we want people to do is to build pipelines. Now we need to have pipelines of different maturities. Obviously, the pipeline that goes into production shouldn't be messed with, but we need to experiment. We have the machines to spin any number of environments and any number of pipelines. And one of the pipelines definitely should be the one that tries different latest from different places and see what actually survives. And if the experiment is successful, we pulled a bunch of new dependencies, and now our application is now more secure, faster, or we can actually use new features that came with those latest. This is where our green experimentation pipeline will be a good sign for us to actually own all those dependencies, stash them in our repository manager, and start relying on them in the production pipeline that actually takes it to production.
Awesome. Baruch, we're at time. Thank you very, very much. Been an amazing session, as always. And thank you very much for supporting all the talks as well. Really appreciate both your and JFrog's support during the whole conference.
This is our pleasure. Thank you for doing that. That's for a good cause. Amazing speakers. Keep rocking. And your session is next, so good luck.
Thank you very much, Baruch, and see you soon, hopefully.
Bye-bye.